Hello class, welcome to this video on 5.5 to 5.8 test version A. So let's go ahead and take a look at those exercises. So number one, it says assume a randomly chosen battery has a probability of 0.8 of working. A remote control requires 2 working batteries in order to work. What is the probability a remote control will work if 2 randomly chosen batteries are put into a remote control? Okay, so here we got 2 batteries. It says we want them to both work. So we have the probability that the first one works and then the probability that the second one works, right? So the probability that the first one works is 0.8. The probability that the second works is also 0.8, right? And so what we do is we multiply those two, right? The probability of working and working. And so we just multiply those 2 probabilities. And so we get 0.64. Okay, so the answer is B. Number 2, there are 8 women and 6 men in a club. A team of 5 has to be chosen. How many different teams can be chosen if there must be exactly 2 women or exactly 4 women? So we see the word or. Remember that word or means that you're combining the probabilities. So the probability of A or B is equal to the probability of A plus probability of B. Okay, so in this case, probability A, exactly 2 women. And it says there are 8 women, 6 men in a club, and we have a team of 5 that must be chosen. So here, order doesn't matter, and because the order in which you choose the women or men doesn't matter, then we are using a combination. All right, so let's go ahead and do the probability that X is equal to 2 women. Okay, let me just say 2 women. So if we're choosing 2 women, then that means we're choosing 3 men, right? So in this case, we have 2 slots, one for woman, one for man. And so we get, okay, so there are 6 or 8 women, and we're choosing 2 of them, right? And then for the men, there are 6 men, and we're choosing 3 of them. And so what do? By the fundamental counting principle, we multiply those 2 together. Well, that's our numerator. And then we need to divide by our denominator, which is everybody, right? Which is, in this case, we have a total of 14 people, and we're choosing 5. Okay, so there's our probability for 2 women, 3 men. And then we want the probability of 4 women and 1 man. So 4 women, 1 man. And so again, it's very similar. The denominator is the same, 14 choose 5. And then for the women, there's 8 choose 4 times, and then do the men, there's 6 choose 1. All right, and so we're able to calculate the answer here. Okay, and we can of course calculate it using Desmos. Desmos is a good math tool for this. So we go to function, and then we get our combination here. So we got, well, first off, let's do the fraction. So we got ourselves, so you say fraction right here, and then we got combination. So we got the combination of 8 women chosen 2 at a time, times, then you got the combination, NCR again, and you got 6 men chosen 3 at a time. And then on the bottom, same, another combination, 14 chosen 5 at a time. And then we add that to the other combination. So now this time we're doing 4 women. So 8 comma 4, and then we have 6 men choose 1, but the denominator is the same. All right, and we got 0.4895. And actually just realized that they don't want the probability, they only want the number of women, the number of ways to do that. So what we can do is we could just get rid of the denominator and figure out what that is. So let's get rid of that denominator, just make it 1. And so there's going to be 980. Okay, so I went back and reread the question. They just want the number of people, not the probability. So in this case, it's going to be 980. Okay, so we won't need the denominator here. So let me just get rid of that, because we don't want the probability, we just want the number. Okay, so let me take out the P because we don't want that. We just want the number of ways to do 2 women and 3 men, and then the number of ways to do this. Okay. All right, and then these are my 2 slots, women, men. Okay, and so we got a total of 980 when we combine these 2 different things. So the answer is D. All right, so let's look at number 3. A deck of cards contains 52 cards. The cards are equally separated into 4 suits. So we got hearts, diamonds, clubs, and spades. A card game is played by shuffling a deck of cards and dealing 5 cards. Which of the following expressions gives the probability that 3 of the cards are hearts and then 2 of the deck cards are diamonds? Okay, so 3 hearts, 2 diamonds. So in this case, now notice that it says 3 of the cards are hearts and 2 of the deck cards are diamonds. This means order doesn't matter. Okay, so order doesn't matter. Okay, so and we want the probability. Okay, so since order doesn't matter, we can get any 3 hearts and any 2 diamonds. Okay, in any order. So 3 hearts, 2 diamonds. So this is similar to the 3 women, 2 men example, where we have the combination. So we have 52 cards and we choose only 5 of them. And then let's do, this is for hearts, and then this is for diamonds. So how many hearts are there? There's, it says there's 4 suits, right? So that means, and there's 52 cards, so that means there's 13 per suit, right? 13 times 4 is 52. And so 13 hearts. So we got 13 hearts and we're choosing 3 of them. And then we got, after that, we got 13 diamonds, right? And we're choosing 2 of them. Okay, and so there you go. So we got 13 choose 3, 13 choose 2, and then multiply those to get the total number of ways to do that. And then, so the answer is C here. Okay, so that's number 3. Now, if they said order matters, then in that case, you would be using permutations here, and the answer would actually be this one, because then you would have 5 cards, and then the order would matter. If they said 3 hearts in a specific order, and then 2 diamonds in a specific order, then you would say, okay, well, then order would matter there. Okay. So then you would need, okay, 13 hearts, then 12 hearts, then 11 hearts. But that's only if order matters. All right, so number 4, Raneem, a student at a local high school, is picking her schedule for next year. She has to decide among the following options: honors English or college prep English, statistics, AP Calculus AB or AP Calculus BC, AP Government or a college prep government, and then be on a sports team, be in a drama class, or a T-trade. How many different schedules does Raneem have to choose from? So again, we have 4 slots, 1, 2, 3, 4. So this is for English, this is for math, right? This is for government, and then this is for extracurricular, so EX, okay? I'll say X for extracurricular. So how many choices does he have for English? Well, he has 2 choices, and then, she has 2 choices, and then for the second option, she has 3, and then for the third option, 2, and then the last option, 1, 2, 3 choices. When we multiply those by the fundamental counting principle, we get 6 times 2 times 3 times 2, 6 times 2 is 12. So we got 36 options. So the answer is C. All right, so that's number 4. So let's look at number 5. How many arrangements can be made of the letters in the word basket, taking 3 letters at a time if no letter can be repeated? And notice that there are no repeats in the word basket of letters. Okay, so there's no repeat letters. So that means you could just do a regular permutation, 3 at a time. Now it says arrangement, so order matters, right? So if I, for example, did ASK, that's 3 letters, that would be a different word than if I did AKS, right? X or something like that. I don't know. So order matters, which means permutation. So we got the permutation of 1, 2, 3, 4, 5, 6 letters taken 3 at a time, which you could just calculate that on the calculator, or you can use the factorials. So 6 factorial divided by 6 minus 3 factorial, which is just 3 factorial. So you get 6 times 5 times 4 times 3 factorial divided by 3 factorial, but those cancel. So 6 times 5 times 4, so it's 120. Again, you can use your calculator for that. All right, so the answer for that one is A. Number 6, how many ways may 10 people divided into three groups of 5, 3, and 2 people? So we start out with 10 people, and so let's do the, we have the group of 5 people, and then we have the group of 3 people, then we have a group of 2 people. Okay, so for the first group, we have 10 people, and order doesn't matter. So I'm going to say order doesn't matter, so it's combination. All right, so 10 choose 5. So 10 choose 5. You have 10 people, and you're choosing 5 for that group. But once you choose 5 people, then you only have 5 left. So at this point, now you only got 5 people left, and you're choosing 3 for the group of 3. And then finally, since you've chosen a total of 8 people, 5 plus 3, now you only got 2 people left. So you got 2, choose 2. So basically, you only got one option. You just put those 2 people into that last group. Okay, you multiply those probabilities together, and you get your total probability. All right. Okay, so we're going to go ahead and calculate this. We got n for the answer. So we got n. So we got NCR. We got 10 choose. I'm not sure what's going on there. 10 choose 5 times NCR, and then we got now we 5 left. Choose 3. And then NCR, and we got 2 choose 2. So we got a total of 2,520. All right, and we go back here. So we get our answer is C, so number 6. All right, so number 7, if 3 coins in a die are tossed, how many different outcomes are there? Okay, so we got 2 different methods, if you will, or actually three coins. So 1, 2, 3, 4. There's 4 different slots. Coin, 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 die. So how many different options for a coin? Well, there's 2, heads and tails. The next one, 2 options. The next one, another 2 options. So die, there's 6 options. So how many different outcomes? Well, you multiply these together. So 2 times 2 times 2, that's 2 times 2 is 4. 4 times 2 is 8. 8 times 6 is 48. And there's a typo in this question, I realize. That should say 48, not 18. Okay. So there's a typo there. All right, so the answer is 48. All right, so number 8, at a local high school, 30% of the students are enrolled in chemistry. Of the students enrolled in chemistry, 60% are enrolled in Algebra 2. Of the students not enrolled in chemistry, 20% are enrolled in Algebra 2. What is the probability that a randomly chosen student from this school is enrolled in chemistry if we know that the student takes Algebra 2? Okay. All right, so it says 30% of the students are enrolled in chemistry. So we got the probability of chemistry is 0.30. And it says of the students enrolled in chemistry. So that's basically telling you the probability of the students enrolled. So that means that they have to enroll in chemistry. So given that they are in chemistry, what is the probability that they're in Algebra 2? Well, they said it was 60%, okay? So you got to understand that that's a conditional probability. Of the chemistry students, the probability that they're Algebra 2 is 60%. And then it says of the students not enrolled in chemistry. So of the students not enrolled in chemistry, 20% are enrolled in Algebra 2. Okay, so we got points 20. What is the probability that a randomly chosen student from this high school is enrolled in chemistry if we know that the student takes Algebra 2? So the probability of chemistry given that they're in Algebra 2. Okay, so a good way to set this up is to basically set up a tree diagram. So we'll set up a tree diagram here real quick. So we got college algebra, or chemistry, sorry, and then Algebra 2. So in this case, so I'm going to say chemistry and not chemistry. Okay, so let's do chemistry and then not chemistry. So here they're saying yeah, so 30% of the students are enrolled in chemistry. So let's do that. So 30%, so that's their 0.30, and then it's 0.70 are not, right? And then we can say Algebra 2 or not Algebra 2. All right, and so in this case, it says the probability that they're in Algebra 2 given chemistry is 0.60. And so that means that the probability that they're not in Algebra 2 is 0.40, right? if they're in chemistry. Now, the probability that they're in chemistry, or that they're not in chemistry, or that in algebra 2, given that they're not in chemistry, is 0.20. So then this has to be 0.80. Remember, these has to add up to 100 or 1. Okay, and they want the probability. They want probability that they're in chemistry given algebra 2. So the formula for this is probability of chemistry and algebra 2. Remember, the formula for conditional probability, I'll just write it out here, is probability of both divided by the probability of the given. Okay, so that's your formula. So we do C and A divided by probability of A, because A is given. So what's the probability of C and A? Well, the probability of C and A is this and this. And so what do we do with those probabilities? We multiply them along the way. So we got 0.30 times 0.60. All right, and then it says, what's the probability of algebra 2? Where that's this pathway, right? Pathway number 1, and then pathway number 2, which is this and this. And again, what do we do with those probabilities? We multiply them. And then we combine these with addition. All right, so we got 0.30 times 0.60, which we did in the numerator earlier, plus, and then the other pathway, 0.70 and 0.20. All right, and we combine those. So we'll do this math here. So we get 0.30 times, we'll do this in parentheses, 0.3 times 0.6 divided by 0.3 times 0.6 plus 0.7 times 0.2. So we get 0.5625. All right, so the answer is C. Okay. All right, so number 9, at a local high school, 30% of the students are enrolled in chemistry. Okay, so this is the same setup, but it says, what is the probability that a randomly chosen student from this high school is enrolled in algebra 2? So the probability of algebra 2, but that's this right here, right? We just calculated that. That's this bottom part. The probability of algebra 2 is, they're taking chemistry and algebra 2, or they're not taking chemistry and they're taking algebra 2, right? So that's 1 and 2 combined. So we just have to combine that. So let's do that here. 0.3 times 0.6 plus 0.7 times 0.2. So we have 0.32. So the answer is D. Okay. All right. So number 10, a fair die is rolled 5 times. What is the probability that 6 lands face up at least once in the 5 rolls? All right, and we'll say, okay, so let's say S is when you lands at a 6, right? So the probability of S for one roll is 1/6, right? 1 out of 6 for a fair die. And we want the probability that it lands at least once. So that means once or twice or 3 times or 4 times or 5 times. Okay, well, the opposite of doing that is not rolling at all, not rolling 6 at all. Okay, so we're going to do the opposite of that. So the probability of at least 1/6 is the opposite of that is the probability of no 6s, right? No 6 in 5 rolls. All right, so at least 1/6 in 5 rolls. Opposite of that is no 6s in 5 rolls. But if I find the probability of the opposite, or the complement, then I have to subtract from 1. So if, for example, this is 40% chance, then this has to be 60% chance, subtract that from 1 to get 40. So it's easier to do no 6s than it is to do at least 1 or 2 or 3 or 4 or 5 or 6, 1 or 2 or 3 or 4 or 5 6s. So we're going to do 1 minus, and then, okay, so then 1 minus, now what's the probability of no 6s in 5 rolls? Well, that means having no 6, no 6, no 6, no 6, no 6, right? So that means, so that's the probability of no 6, so S prime meaning no 6, and no 6, and no 6, and no 6, and no 6, right? 1, 2, 3, 4, 5 times. Well, that's just going to be the probability of no 6. The probability of no 6 is 5 out of 6, right? So the probability of no 6 is 5 out of 6. So then it's just multiplying 5 out of 6 a bunch of times. no 6. So it's going to be no 6 times the probability of no 6 times the probability of no 6. So basically it's just this to the fifth power. So it's going to be 1 minus 5 over 6 to the 5th power. Okay, so that would be the fastest way to do that problem. So we just get 5 out of 6 to the 5th power. So we get 0.5981. So the answer is A. All right, so number 6, in how many ways can a committee of 6 people be chosen from a panel of 10 people if a certain person must be on the committee? Okay, well, if you think about it, there's 6 people, 1, 2, 3, 4, 5, 6, right? There's 6 people, but then this spot is taken, right? So this is already taken. So that means one person must be in that spot. So one person is in that committee. That means you got 5 left, right? So there's one way to choose one person in that committee, and then you got to multiply that by then look at the other ways. Okay, so then how many ways do we have of choosing the other 5 people? Well, I mean, that's just going to be a combination, because order doesn't matter. And then there's 9 people that you have left to choose from because you have 1 already chosen. And then you have 5 people left to be on the committee. So it's just really going to be 1 times 9 choose 5, but 1 times anything is just that. So it's going to be 9 choose 5. So 9 factorial divided by 5 factorial times 9 minus 5 factorial, which is 4 factorial. So 9 times 8 times 7 times 6 times 5 factorial. 5 factorials cancel. 4 factorial, 4 times 3 times 2 times 1. All right, and we know that 6 divided by 3 is 2. I'm just going to simplify and do the math. And then 2's cancel out here. And then a 1 we can just basically ignore. And then 8 divided by 4 is 2. So now we got basically 9 times 2 times 7. So 18 times, or 63 times 2, which is 126. So the answer is A. Okay, but you could do this with a calculator, but I just, of course, looking at this, you can technically do this without a calculator. The numbers aren't that big when they cancel out. All right, so number 12, a weather forecaster claimed the chance of rain next week on Monday is 50%, and the chance it rains on Tuesday is 80%. Is the probability that it rains next Monday and Tuesday equal to 40%? So what they're trying to do here is, okay, with the probability of rain on Monday and rain on Tuesday, what they did is they just multiplied the 2 probabilities, rain on Monday times rain on Tuesday. And then they did, okay, 0.50 for Monday and 0.80 for Tuesday, right? And so when I do that, I get 0.40 for both days if it rains. But is that necessarily true? And the answer is not really, because the chance of rain on Monday or on Tuesday may depend on Monday. So if it rains on Monday, it may actually reduce the chances of it raining on Tuesday. Or if it doesn't rain on Monday, then it might increase the chances of raining on Tuesday, right? So there's a relationship here, and so they're not independent. So this is not true because they're not independent. Okay, so we have to realize that for that question. It's just the idea of they're not independent. Okay, so no, because the chance of rain on Monday and chance of rain on Tuesday are not independent. They depend on each other. All right, so number 12 is B. All right, number 13, Catherine is playing a game that uses the 4 aces from a deck of cards. She shuffles the 4 cards and places them face down on the table. In how many ways can Catherine place the 4 cards on the table? Okay, so here it says how many ways can she place the 4 cards? That means order matters, right? Meaning that you have 4 slots, 1, 2, 3, 4, and then you have 4 aces, or these are all aces, right? Ace, 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 ace. So here we have 4 choices for our ace. Then after we choose one of those aces, then we have 3 left, then 2, then 1. In other words, this is just a permutation of 4 permute 4, which is just 4 times 3 times 2 times 1. So that's going to be 24 ways. So it's a permutation, or you can use fundamental counting principle. All right, so a crossword game is played by 2 players. The game has 100 tiles, so that's important, and there is 1 letter on each tile. Okay, and then the 100 tiles, so that means there's 20, there says there's one letter, that's 26 letters in the alphabet. The 100 tiles are placed in a bag and mixed thoroughly. The first player reaches in the bag and selects 7 tiles. How many different sets of 7 tiles can the first player choose? Okay, so here the order doesn't matter, right? So because if I chose A, B, C, D, E, 2, 4, 5, 6, 7, that's the same thing as if I chose G, A, B, C, D, E, F, right? If I just reversed the order or put G up first. So this is a combination. Order doesn't matter. So we know it can't be C or D. And we have 100 tiles and we're choosing 7 of them. So it has to be just that, 100 choose. In this case, 100 choose 7. Okay, so in this case, this part is just irrelevant. You just need to know there's 100 tiles, and then there's 7. And there's probably different. There's probably not just alphabet letters. There's probably other types of letters in there, so you can get 100 tiles. But all right. So for number 14, the answer has to be A. All right, number 15. 10 singers have signed up for a signing competition. The order in which they will compete is selected by a random draw. Okay, so 10 singers. 5 of the singers will compete before an intermission, and 5 will compete after the intermission. All right, so that basically they're saying, okay, so you need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 5 are going to be will compete before, and then the other 5 will compete after. So that means they're different, right? That means that order matters. So if I chose some here and then I put them here, well, then they're now going to sing after. So order here matters. We want to be careful with that. How many different ways are there for the 5 singers to be selected to sing before the intermission? Okay, so here actually they're only saying how many different ways are there for the 5 singers to be selected to sing before the intermission. Okay, so we're only doing this part right here. We only care about that before, according to what they're saying here. Okay, so then let's just focus on before. Well, in that case, if you're only looking for the ones before, then it doesn't really matter in that case, right? Because I could just choose any before. All right, so then we can ignore the A, and here then order doesn't matter. Okay, so before, if we took them together, it would matter. But here, it's just all the same thing. Okay, so order doesn't matter, so combination. All right, so then we got how many people? This is for before. We got 10, or how many singers in total? Oh, well, the 10 have signed up. Okay, so it says 10 have signed up. All right, well, in that case, there's 10 singers, and you choose 5, and that's it for that one. So 10 choose 5. All right, and then so then we can calculate that, see what that is. So actually now looking at it, it says the order in which they will compete is selected by a random draw. So it's actually order does matter. So order does matter. Okay, sorry about that. So I did that one little thing, that one little sentence there. So order does matter. So that means if I put Anne first before Beth, then Anne's going to go first, then Beth. Otherwise, if I put BA, then Beth will go first, then Anne. So here, the order matters. So we're going to use a permutation instead. So permutation of 10 objects, 10 singers chosen 5 at a time. All right, and then so let's calculate that. Okay, again, when you go to Desmos function, and then you got permutation right there. So we got 10 people chosen 5 at a time. So 30,240. All right, guys, so then here the answer is A. All right, number 16, it is known that a certain disease occurs in 5% of a large population. Okay, test for the disease has a positive result 90% of the time for people with the disease. What's the probability that a randomly selected person has the disease and tests positive for the disease? Okay, so the probability of a disease is 0.05. The probability of testing positive is 0.90, right? And the probability of disease and positive, that's what they want, and positive. So when you have 2 outcomes, remember you multiply them. Probability of disease times probability of positive. Okay, so positive given disease, I guess you can say positive, because they have to have a disease, right? So you just multiply those 2 probabilities. So let me write positive given disease. So multiply those two, so you get 0.05 times 0.90, and so you get 0.045. The answer is A. All right, how many 4-digit numbers greater than 3,000 can be formed, and you have 4-digit numbers, using 1 through 7, if repetitions are allowed? Okay, so we got 1, 2, 3, 4, and it has to be greater than 3,000. So greater than 3,000, meaning greater than or equal to 3. Okay, so that means that, for example, we could get we could use 3120, 3,120. That number can be 3. Because that's bigger than 3,000. We could do 4,120. We could do, or we can't use 0 because that's that. So let me just do that. 4,123 and so on and so forth, right? We could use 3, 4, 5, 6, or 7 for the first digit. So that means, let me write this down. So for the first digit, I can use 3, 4, 5, 6, or 7. Which means 1, 2, 3, 4, 5 options. I got 5 options here for that first digit. Now, it says repetitions are allowed, so I can repeat that. So even if I choose one of these ones, it's not going to affect my count. Okay. Now, they just want it to be greater than 3,000. So at this point, we got 1 through 7. That's a total of 1, 2, 3, 4, 5, 6, 7. That's 7 numbers from 1 through 7, right? So 1 through 7, 1 through 7, 1 through 7. So at this point, we just have 7 numbers to choose from for each of those because repetitions are allowed. So then you can multiply 5 times 7 times 7 times 7. And let's see what that is. 5 times 7 times 7 times 7 is 1,000. Okay, so there's a typo here. This number right here should be 1715. So that's a typo. That number 1372 is if you assume this is 4 times 7 times 7 times 7, which is incorrect. Because I guess in the solution, they didn't include 3. They only included 4, 5, 6, or 7. So that's 4 times 7 times 7 times 7, which is 1372. But you can include 3 because being greater than 3,000 can be a 3 there. So it has to be 1715. Okay, so the answer is C, but it should say 1,715. All right. Okay, and then I will, of course, I'll make allowance, for these questions if there's a typo in there, and I won't, this is why we curve it and give points and look at the questions just in case there's a typo in the question. All right, so number 18. Okay, so a deck of cards contains 52 cards. Okay, so they talked about that before for cards. So what is the probability that the 5 cards will all be hearts? Okay, so 1, 2, 3, 4, 5. So hearts, basically. But it says the order doesn't matter. So really, order doesn't matter here. So because it just says all will be hearts. So order doesn't matter, which means we could just use a combination. So we want all of them to be hearts. So there's, what's the probability that all 5 cards will be hearts from the deck of 52 cards? All right, so 52 cards, and okay, so in this case, we have the probability of 5 hearts, right? In this case, it's okay, well, we got 13 hearts, right? Because there's 4 suits, 13 hearts, 13 for each suit. And we're choosing 5, right? And then out of the total 52, choose 5. There you go. Here order doesn't matter, so we use a combination instead of a permutation. So let's calculate that. All right, here we go. So on the calculator, we're gonna do a fraction, and then we're gonna use combination. Okay, so NCR, and we got 13 cards, choose 5, divided by NCR, 52 cards, choose 5. So there's my number. So it's basically rounds to like 5, and then move this decimal place 4 to the left. 1, 2, 3, 4. So it's going to be 0 point, and then you're going to have 3 zeros, and then 495. Okay, so let me write that number down. It was 4.95 times 10 to the negative fourth power. So you're going to move it 1, 2, 3. So you got 4. So 1, 2, 3, 3 zeros, and then 495. But then that rounds to 0.0005-ish. Okay, so the answer is D. Okay, hopefully that made sense. And then number 19, A, B, C, and D are 4 students. And how many ways can they be seated in a row if A and D must sit at the ends? All right, so A and D must sit at the ends, right? So we got 1, 2, 3, 4. So we can have A and D, for example. And then here, you could either choose B or C at this point, right? Or B or C. So if I chose, that means we only got 2 choices. Let me just write here, A and D. So A and D must sit at the ends. So there's only one way for A to be there and one way for D to be there. It's just put them in there, right? And then there's 2 ways of choosing the second student. But then if I choose one of those students, then I only got 1 student left for that last slot. But we can't just have AD. We could have DA, right? So we could have D sitting on the left end and A sitting on the right end. So we could have that, right? So then we only have 2 choices and then 1 choice. So basically it's just AD or DA, and then we just basically have the other ones. So we combine these. We combine these 2 different combinations. All right, so we got 1 times 2 times 1 times 1, and then 1 times 2 times 1 times 1. We just multiply them. Okay, but this is just 2. There's only 2 ways to do that. Plus, there's only 2 ways to do that. So it's 2 plus 2 or 4. All right, so the answer for number 19 is B. And you can list out those ways if you want, and you'll see that there's 4. It's easy to list them out, right? We just kind of listed them out already. Let's list them out. So we get A, B, C, D. We can get A, C, B, D. We can do D, B, C, A, or we could do D, C, B, A. And you can see that there's only 4 ways for A and D to sit at the ends, okay? All right, so number 20, 50 people take part in a Call of Duty multiplayer competition, 50 people. Assume each team consists of 10 players. How many different teams of 10 are possible? So here, order doesn't matter, right? You could just choose any 10 people for the team. So in that case, order doesn't matter, so use a combination. So we got 50 people, choose 10. And that's it, guys, 50 choose 10, and you get your answer. So the answer, if you put this on the calculator, we get C. There's 10,272,278,170 ways to form those teams. All right, so we're looking at the free response questions. So starting at number 15, the Bluebird Diner employs 3 dishwashers. Al washes 40% of the dishes and breaks only 1% of those he handles. Deborah and Carl each wash 30% of the dishes, and Deborah only breaks 1% of hers, but Carl breaks 3% of the dishes. Suppose we randomly select a dish that's been washed. Draw a tree diagram to model this chance process. Okay, so first we're gonna we have Al. Then we have Deborah, and we have, Deborah and Carl. Okay, so Al washes, it says, okay, so it says Al washes 40% of the dishes, and we have Deborah and Carl wash 30% of the dishes, for a total of 100%. Now, of the dishes that Al washes, he only breaks, so we'll put B for breaks, B for not breaks. He breaks 1%, so that means 99% of the dishes he does not break. Deborah, same thing, 0.01, and then we got 0.99. And for Carl, he breaks 3% of the dishes, so 0.03, which means that 97% of the dishes are not broken. Okay, so there's a tree diagram for the process. Find the probability that the dish is not broken. So the probability that it's not broken, B prime. So again, we have to travel here, here for not broken, here, here for not broken, and here, here for not broken. So we got to travel each of those pathways. Pathway 1, pathway 2, and pathway 3. And then we have to combine those pathways, right? We're going to remember, as we travel each pathway, we multiply the probabilities along the way, right? So that pathway, we multiply those two probabilities and so on. Then we combine them, okay? So for the first pathway, we got 0.40 times 0.99. So that's pathway number 1. Pathway number 2 is 0.30 times 0.99. And then pathway number 3 is 0.30 times 0.97. And we just combine them. All right, so we'll go ahead and multiply these together. 0.4 times 0.99. Okay, so we got 98.4.984. So 98.4% of the dishes have a chance of not being broken. All right, so and then given that the dish is broken, what is the probability that Carl washed it? Okay, so the probability given that it's broken, the probability that Carl washed it. Okay, so P of C given B. Remember, the formula for this is the probability of C and B, the probability of both events, divided by the probability of the given event. All right, so given that the dish is broken. Okay, so now let's do the probability of Carl and broken. So let me do these pathways in purple, all right? So we got this 0.40, this pathway. So that's pathway, I'm just gonna call it A. And then broken for Deborah is that pathway, so we'll call that pathway B. And then here, pathway C. Okay, so those purple pathways are the broken pathways, right? So we're gonna do pathway C for Carl and broken, right? So we're gonna need to do 0.3 times 0.03. 0.30 times 0.03. Over, now we're gonna do the three pathways. We're gonna combine the three pathways for broken, all right? So we need to do that. Okay, so the first pathway is 0.40 times 0.01. That's pathway A here. We got pathway B, 0.30 times 0.01. And then we got pathway C, which is the one we got on top, which is Carl and broken. All right, and then there's going to be our solution. So let's see, what does that come up to? All right, so on the numerator, put that in parentheses. Denominator, we put that in parentheses. Okay, we get about 0.5625, 0.5625. So given that the dish is broken, there's a 56.25% chance that it was Carl that washed it. Okay, so it's more likely than not for Carl to have been the one that washed it, which makes sense because Carl breaks 3 times as many dishes. The rate is 3 times as many dishes as the other two. All right, so number 16, a soccer team has 11 players on the field at the end of a scoreless game. According to league rules, the coach must select 5 of the players and designate an order in which they will take penalty kicks. So we got 11 players, we got to select 5 of them, and there's an order, okay? So this is a permutation or combination. This is going to be permutation since order, okay? So permutation, because order matters. In which they will take penalty kicks. Okay, so here order matters. We're going to use permutation. How many different ways are there for the coach to do this? So this is permutation. So permutation, 11 people, players chosen 5 at a time. So then we're going to show our work. 11 factorial divided by 11 minus 5 factorial. That's 11 factorial divided by 6 factorial. So 11 times 10 times 9 times 8 times 7 factorial. Oops, we're going to stop at 6 factorial over 6 factorial. So then these cancel. We just got to do 11 times 10 times 9 times 8 times 7. So we have 55,400 ways for the coach to do this. All right, that takes care of number 16. And then number 17, at the end of the week, each week, a department manager gives a small bonus to a few randomly selected employees. There are 25 employees in the department, 11 males and 14 females. She wants to give a bonus to 6 of her employees. Is this a permutation or combination? All right, so it's a combination since order of people selected does not matter. All right, how many possible groups of 6 employees can she choose? So then it's a combination, right? So we got, it says she wants to give bonus to 6 of her employees. Okay, so that means it's just 25 choose 6, right? So 25 factorial divided by 6 factorial times 25 minus 6 factorial. So 25 factorial divided by 6 factorial times 19 factorial. We got 25 times 24, 23, 22, 21, 20, 19 factorial. We're going to stop there. That way we can cancel that out. And then 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. And we could do this on the calculator at this point, but at least, you know, we showed that we can cancel factorials and things like that. And then we get our answer, okay? And we could do this on Desmo, since you'll be doing this on a calculator anyways. Okay, so in here we're going to do 25 choose 6 here, and we guess 177,100. All right, so we got 177,100 possible groups. All right, so now find the probability that she gives a bonus to 3 males and 3 females if she chooses them completely at random. So we got 3 males, 3 females. So we have 2 slots over the total, right? The total that we got was 25 choose 6. We got male, female. So now remember that if we go back to the problem, there are 11 males and 14 females. Okay, so 11 choose 3 for the males, and then 16 females choose 3, right? 14, sorry, not 16. 14 females choose 3. All right, and then we're going to multiply this in the numerator, and we already know what the denominator is, but then we're going to get this as a probability. Okay, all right, so let's go ahead and do the calculation. So we got to do a fraction. We're going to do NCR. We got 11 choose 3 for the males times 14 choose 3 for the females divided by 25 choose 6 for the total. So we get 0.339 for the probability. All right, so we get 0.339 chance for her to give the bonus to 3 males and 3 females. All right, that's going to do it for the video, guys. Hope you found this useful and informative as usual. I'll see you in the next one.